Welcome, ChemCom. Today we're going to move on to our third type of chemical reaction, which is decomposition, or when we have one reactant breaking apart into different parts. Let's get started. We've already gone over the definition of decomposition reactions. You're typically going to have one reactant, and that reactant will split or break into different parts. Sometimes those different parts will be pretty obvious. Other times it'll be a little more complicated. There are multiple types of decomposition reactions that you need to be aware of, and we're going to go through them now. Just a quick side note, most of the time decomposition reactions will require heat to initiate the decomposition. And because of this, most of these reactions would be considered endothermic. I want to draw your attention to your equation sheet. We're about ready to go through multiple types of decompositions, and sometimes students have a tough time keeping them straight. We provide for you the word equations for these decomp types on your equation sheet. So I would find this section on your equation sheet so that as we walk through these, you can see that you have this information in front of you. And it'll help you predict products better and hopefully make it easier to remember. The first type of decomposition is when you have something called a metallic chlorate. This is a metal binded with a chlorate, which is an anion, and it will decompose into a metal chloride, that's a metal, and chlorine, and oxygen gas. An example would be sodium chlorate is heated. So if we have sodium chlorate, we have Na, and then chlorate is ClO3, and sodium's a +1 and chlorate's a -1, so they go together easily. That is typically going to be a solid that we heat, and that's going to decompose into a metal chloride, that's sodium and the chlorine. Sodium's a +1, chlorine's a -1. That'll typically stay solid. And then oxygen gas, which we know is diatomic, therefore it is O2, and they told us it's a gas, so it's G. The next thing we'd want to do is balance this. So you can see that we're going to need a 2 here, a 3 here, and then a 2 here, and that will balance our decomposition reaction. So with decompositions, we tell you what's going to happen. Your job will just be to figure out what those products are and balance accordingly. Here's another example of a metallic chlorate decomposing with gallium chlorate, and it is balanced as well. The second type would be a metallic carbonate. It's a lot like the last one. We have a metal combined to carbonate, and when it decomposes, it produces carbon dioxide. So we have lead 2 carbonate. Lead 2 is a +2, carbonate's a -2. So this is going to be PbCO3, and that is solid. And when it decomposes, it forms a metal oxide. That's metal and oxygen. So PbO, because lead is a +2, oxygen's a -2, that'll stay solid. And then we'll have a CO2 gas that is produced. This one is actually already balanced. Nothing further is needed to do. You can see down here we have aluminum carbonate that decomposes. It is also balanced. The third type would be a metallic hydroxide. This is actually going to decompose into a metal oxide and water vapor. So if we look at lithium hydroxide here, we have lithium hydroxide, and lithium and oxygen bonded together would form Li2O because lithium's a +1. That's our metal oxide. And then water vapor would be H2O, and we put that as a gas because it's vapor. Remember, we're adding heat to this, and that's why it's going to be water vapor. Here's another example with titanium hydroxide, and we have our titanium oxide and our H2O on the right. Certain types of metal oxides, in order to be purified, will be heated to separate the oxygen from the metal. This is one way to purify metals that are pretty stable and are useful in infrastructure and jewelry. Think of metals like gold, platinum, and silver. If we look down here at the bottom, we see this is mercury oxide. It's a mercury atom bonded with an oxygen. It's solid, and as we heat it, it decomposes just into the element mercury and to O2 gas. Remember, mercury is a liquid at room temperature and standard pressure. Where down here with gold oxide, you can see that this gold is staying solid because gold is solid, typically at room temperature and standard pressure. In this one, you just have metal and oxygen separating from one another into their elements. Acids are also something that decompose over time. Lots of different acids do this, but there's only 2 that you need to know, which are carbonic and sulfurous. Carbonic acid is H2CO3, and remember, all acids are aqueous. This will decompose into water and CO2. and sulfurous acid will decompose into water and SO2. This is why if you let acids sit for a really long time, the molarity or concentration of those acids actually changes. Both of these decompositions are on your equation sheet, but you'll have to recognize that they're acid decomposition. The final one here is the electrolysis of molten salts. This is when you have a salt and you're trying to separate it into its element. So if we have lithium bromide, it is molten, that's why we write this as liquid, and as we run an electric current through it and heat it up, it will separate into lithium metal and the bromide non-metal. Lithium is liquid because it's molten. We're still in the presence of a lot of heat, so we still record the state as liquid. And then bromide is also liquid, but notice it's diatomic because bromine is diatomic. Same thing down here with calcium chloride. It's liquid, calcium is still liquid. Notice with chlorine it's also diatomic, but we've also put that it's gas. If chlorine is gas at normal temperatures, at these hot temperatures of molten salts, it's going to be in the gas phase. I know we just showed you a lot of different models of decomposition reactions, but if you look back to your equation sheet, you'll see that most of the notes are already there. It tells you what you're starting with and what they would decompose into. It's just your job to come up with the correct formulas for those metallic chlorates and metallic oxides and whatever else that is in that equation. Use the equation sheet, work through it methodically. Let me know if you have questions. Keep up the good work. We'll see you soon.